So in this video, we'll discuss about the MOSFET, which is metal oxide semiconductor field effect transistor. So it's one kind of a field effect transistor which is used as an amplifier like the BJT, but it is widely used. A MOSFET is widely used in amplifiers because of their infinite input impedance. And when you compare to the BJT, nearly no input current for controlling the load current. And the MOSFET is classified into two types, enhancement and depletion MOSFET. So we'll see what is the difference between enhancement and depletion MOSFET. So the types of MOSFET, as I said, MOSFET is enhancement type and the depletion type, and depletion and enhancement is further classified into two based on the channel. So N channel enhancement, P channel enhancement, N channel depletion mode and P channel depletion mode. And this is the difference between enhancement and depletion. So what is the difference you can see? The differences in the channel. So here in the structure like the JFET, there are three terminals: source terminal, drain terminal and gate terminal. Even here, source, drain, gate, three terminals are there. In addition to that, there is a substrate. This box, if you see, this is a substrate. Okay, and one difference is the channel. The channel is absent. Here the channel will be created. It is absent in enhancement type, but the channel is present in the depletion type. Okay, the channel is absent because the voltage is not applied in this enhancement. When we apply voltage to the gate terminal, the channel will be created, but in the depletion type, the channel is already created. Okay, so this is the main difference between enhancement and depletion. Channel is absent, but channel will be created when we apply the voltage to the gate terminal. Okay, so we'll see first the enhancement mode in this video, and in the next video we will see the depletion. And in enhancement, first we are going to discuss about N channel. If you understand N channel, then P channel will be easy. So here three terminals are there: source, gate and drain. So as we discussed in JFET, source is the terminal where the majority charge carrier enters the channel, and drain is the terminal where the majority charge carrier exits the channel. And the gate is very important in enhancement because after applying gate voltage, the channel will be created. That we'll discuss how. So this type is called the enhancement type. Means the voltage at the gate terminal will enhance the channel, making it capable of conducting current. Because if there is no pathway between the drain and source, if there is no pathway at all from drain to source, then there is no current conduction. So pathway will be created after applying the voltage to the gate terminal. Okay, so we'll see the construction of enhancement. So this is a symbol of enhancement MOSFET for N channel and P channel. The difference is in the direction of the arrow mark. So drain, gate, source, and in addition to these three, there is one more called the substrate. Okay, so we'll see what are all these things in the construction. So this is a construction of N channel. Okay, this is a construction of N channel enhancement. N channel enhancement. So what is its structure? So this box is, this silicon box, this is the substrate, and substrate which is made up of P-type. The substrate, this box is a substrate which is made up of P-type. P-type which is having holes as majority charge carriers, and it is positive charged particle. And if you see the drain and source terminal, the drain terminal and the source terminal are diffused, or we can say it is inserted in this P-type substrate. Okay, so this full box is a substrate, and this drain and source are diffused. Okay, and this drain and source which consists of N-type semiconductor. Okay, N which is having the electrons as majority charge carrier. Okay, so as we know, the source is the terminal where the majority charge carrier enters the channel, and drain is the terminal where the majority charge carrier leaves the channel. So for the movement of electrons from drain to source, there should be some pathway. Okay, that pathway will be created by the channel. Okay, so in enhancement, the channel is absent. After applying gate voltage, the channel will be created. Okay, so for now construction, you should know about what is source and what is drain, and where the channel comes, and what is a substrate which is P-type, where there will be abundance of holes. Okay, this substrate will consist of holes as a majority and electrons as a minority charge carriers. And this SS is a substrate. And the gate terminal, this gate terminal is connected to the substrate, means it is connected. It is not connected actually to the substrate because it is insulated. So you can see the gap. This is made up of SiO2, or we can say it is a polysilicon. So the gate is insulated from the substrate. Okay, if you see drain and source, it is connected. You can see the connection. Drain and source are connected to the p-type substrate, but the gate is insulated from the p-type substrate. So what happens is, this whatever you apply the gate voltage here, that doesn't attract the majority charge carriers towards the gate terminal, because this SiO2 prevents the flow of majority charge carrier towards the gate terminal. Okay, so the drain and source are diffused into the p-type substrate, but the gate is insulated from the p-type substrate, and this substrate is P, and the channel will be created by the n-type. So this is called as a n-type enhancement mode. So this is about the construction as we discussed. So substrate, there will be a substrate here. The substrate is which is made up of p-type. P-type is having holes as majority charge carriers, and source and drain means source and drain both are n-type, where the electrons are majority charge carriers. So there should be a pathway, that is a channel, that will be created once we apply the voltage to the gate terminal. So once the channel is done, the flow of electrons starts from the drain, and it reaches the it starts from source and it reaches the drain after the channel creates. Okay, so source is a terminal and gate is another terminal. Drain is another terminal, and gate is a terminal which is insulated from the substrate by SiO2 polysilicon. So this is about the construction, and next we'll see the working. And here we are going to use two voltages, VDS, which is a voltage between the drain and source, and one more is VGS. We'll see what is the importance of VDS and VGS. Okay, so first case where VGS is equal to 0, VGS equal to 0, and applying VDD. Okay, so what happens when you apply VDD? VDD is nothing but VDS, means the voltage across drain and the source. Okay, so even if you apply the voltage across drain and source, there won't be any movement of electrons, because there is no pathway at all between the drain and the source. So no current conduction, no current flows from source towards the drain, because the channel is not created. Okay, so even though you apply VDS and VGS is 0, even though when you apply VDS, there is no flow of electrons from source towards the drain, because no pathway. Okay, I hope you understand this case. And second case where we are applying VGS and we are making the VDS as 0. Okay, we are checking what is the importance of VGS. So I already said this is an enhancement mode and channel is absent. Okay, so when we apply VGS, and here why we are connecting positive polarity and negative polarity here, because the electrons, it should start from source and it should reach the drain. So the electrons are negative charged particle, and negative, it should repel by this source and it should be attracted by the drain terminal. Okay, so the negative and the negative is connected. Okay, so the negative which repels the electrons from source towards the drain. So for that, this battery. Okay, and now, so what happens when you apply VGS? Okay, when VGS is applied, the channel will be created. So how the channel is created? So see this polarity. This side is negative because it has to repel the electrons once the channel is done. Okay, so this will be positive automatically. So this plus, when you apply the positive voltage to the gate terminal, what happens is the p-type, which is having the holes as positive, that will be repelled towards the substrate terminal. Okay, so this full substrate is having the holes as a majority charge carriers. Okay, so this positive voltage, that will repel the majority charge carriers in this substrate towards means against, means it towards the source, means all the majority charge carriers moves away from this. Okay, so and next what happens when you keep on increasing the VGS? Okay, so the holes which is going away from this, okay, that this positive, that will repel the positive holes. And when you apply the VGS, what happens when increase in VGS attracts the minority charge carriers towards this. Okay, so when we apply the positive voltage, this positive voltage repels the holes towards the substrate, and it starts attracting the electrons. So if you see here, the holes will be repelled. Holes will be repelled, but minority charge carriers will be attracted, and it comes near this because it reach the gate because there is a SiO2, there is a insulation. Okay, so the electron, the minority charge carriers, that forms a channel here. Okay, the minority charge carriers that will be settled here. So I hope you understand. When we apply VGS, this positive voltage that repels the holes towards the substrate and it attracts the minority electrons towards here. Okay, so this negative electrons, okay, so this layer is called as the inversion layer because the substrate is P but the electrons are formed here, no? So it is an inversion layer and this forms a channel. Okay, so that's the use of VGS. In enhancement, the channel is not there, but when you apply VGS, because of the minority charge carrier attraction, they will form a channel between the drain and the source. Drain and the source. So now the channel is created. Okay, that's what it is mentioned. Due to the minority charge carrier, the channel will be created between the source and the drain. And next, when you keep on applying the voltage VGS, and when it reaches the threshold voltage or when it is more than the threshold voltage, what happens is the channel will be completely created. Okay, the channel will be completely created when VGS is greater than some threshold value, and even the depletion layer will be formed. The depletion layer will be formed. So you can see here the channel is created and even the depletion layer will be created like this. Okay, so now the channel is N, and next what happens is with the help of VGS the channel is done, and next there should be a current conduction. Okay, so till it reaches VT there is no current at all. So once it reaches the VT threshold voltage, the channel is completed and we have to think about the VDS. Okay, so the channel is created, the depletion layer is formed, and now it's about applying VDS, the voltage across the drain and the source. So now what happens when you apply voltage across the drain and source? So this positive, so what is it, positive polarity here? It should attract the electrons. Okay, the negative here, it should repel the electrons. So the electrons will start moving from from source towards the drain. Okay, so the movement of electrons takes place from source towards the drain, and when the movement gets increases due to the increase in the VDS, what happens is the depletion layer will be more. It is more in the upper portion than the lower portion because the movement is from towards the upward direction from source towards the drain. Okay, so the depletion layer will be formed more in the drain, near the drain terminal compared to the source terminal. And when the depletion layer increases, the channel width decreases. Okay, if you see the previous diagram, the channel width is equal, and if you see this place, the width is decreasing near the drain terminal. Okay, and that's what. So VGS is greater than VT anyhow. After that condition, the channel will be created, right? The channel will be completed, and now we are applying VDS, voltage across drain and source, that will attract the electrons from source towards the drain, and there is a current conduction, ID flows. Okay, so now we are going to discuss about the pinch off condition. So what is a pinch off condition? So when more number of electrons moves from source towards the drain, okay, when the more number of electrons starts from source towards the drain, what happens is the depletion will increases and the channel width decreases and the pinch off occurs. If you see, this is a pinch off condition. So once a pinch off is done, then the movement of electrons will be restricted. The movement of electrons will be restricted from the source towards the drain, and the current will be stable. A constant current will flow once a pinch off condition is done. Okay, so what are we can say, when the voltage across the gate and source and drain and source, okay, is minus VGS minus VDS is attained, means it's nothing but threshold voltage. When the difference between these two voltages is equal to threshold voltage, the pinch off condition occurs. Okay, so the pinch off occurs and the current will be stable. So if you see the drain characteristics, we are increasing the voltage across gate to source voltage. Okay, when we increase the gate to source voltage, what happens? The drain current increases. So this is a drain characteristics. And here you can see the ohmic region. This is the ohmic region. This is a ohmic region, and this is a saturation region, and this will be the cutoff region. Okay, and this drain characteristics is same as your JFET, VDS versus ID, but in JFET it is like 0, 1, 2, 3, 4, 5 like that. It means it increases in this order. But here for the maximum gate source voltage, the current ID will be maximum. Okay, and the transfer characteristics. So what is the transfer characteristics? It is VGS versus ID. So when VG is equal to 0, the current is 0 because no channel is formed. When VGS is greater than VT, the threshold, then what happens? The channel will be completed. So till that the current is 0 only. Once the channel is done, means once VGS is greater than VT, the channel is done, and there will be an increase in the drain current when you apply VDS. Okay, and that's about the N-channel enhancement mode. And now we'll see about the P-channel enhancement mode. The difference is the substrate is N-type, which is having the electrons as majority charge carriers, and the electrons are negative charged particle. And this one, drain and source, which is made up of a P-type semiconductor, and the channel is absent because it is enhancement mode. The channel will be created once the gate voltage is applied, and the gate is insulated from the substrate, and drain and source are the other two terminals, and this SS is a substrate. So this is about the construction, and if you see the working the same, the channel will be absent in first. So now what happens? The first case is VDS. If you apply VDS and VG is equal to 0, what happens? The channel is not at all created. So even though you apply VDS, the movement of holes that doesn't takes place from the source towards the drain because the channel is absent. And once the VGS is applied, then what happens? This negative voltage, why it is negative? This positive has to repel the holes from source towards the drain, right? So the positive means the VGS is negative here. So when we increase the VGS, and what happens? This negative that repels the electrons towards the substrate, and it attracts the minority holes towards this. So holes will be formed in this junction, across the junction, and when VGS, when it is greater than VT, what happens? Why it is minus? Because VGS is in minus, no? So when the VGS is greater than VT, the channel will be completed, and the depletion layer will be created. And next, when you apply VDS, what happens? This negative polarity that will attract the holes towards the drain from holes, because this positive repels the holes, and the this negative attracts the holes. So there is a movement of holes from source towards the drain. So the current conduction takes place. And when we increase this VDS voltage, the depletion layer will be more, and that decreases the width of the channel, and finally it will be pinched off. The channel will be pinched off, and the current conductions will be restricted from source towards the drain. So the same whatever we discussed in the N-channel enhancement mode, but here the current conduction is due to the majority charge carrier holes. Okay, so this is what about the enhancement P-type mode, and the drain characteristics is same, but this voltage just will be VGS and VDS both are negative here. Okay, so the voltages will be in a negative, VDS versus ID, and the transfer characteristics, since the VGS is in negative, it comes in the second quadrant. The rest all the concepts are same. So this is about enhancement N-type and P-type mode.